Properties of matrices of real numbers. We're at 13.4D with 11 previous videos for this chapter that are linked in the description if you need to go back. So remember the rules to add or subtract matrices. They must have the same dimensions. And to multiply matrices, matrix A needs to have the same amount of columns as matrix B has rows. And with the appropriate dimensions, these properties hold for matrices A, B, and C, whatever they are. And the commutative property of addition, now it's not multiplication because it doesn't work for commutative property of multiplication. But for addition it does. We can have matrix A and matrix B and add them together and we'll get the same thing as if we added B plus A. Doesn't matter the order, it's commutative. And the associative properties holds true for addition or multiplication. We can add these two matrices together and then add A, or we could add A and B together and then add C. We'll get the same thing. They'll equal each other. And for multiplication, we can multiply these two together and then A, or multiply A and B together and then C. They'll be equivalent. And additive identity, it says there exists a unique matrix O. It's a letter O, that A plus this O is going to equal O plus A. It's still going to equal A. See, this matrix O is a zero matrix. Everything inside of this matrix is a zero. And if we add a zero matrix to matrix A, well, matrix A is going to maintain its identity and stay the same. No different than if we were to add 5 plus 0, it's still going to be a 5, isn't it? And we've got additive inverse property. And there exists a unique matrix, the inverse of A, so that if we add A to the inverse of A, we're going to get that zero matrix again. We're making a zero pair, aren't we? It's the additive inverse. And the distributive property, that works for matrices. We can add B and C matrices together and then multiply it by A. It's going to be the same thing as if we multiplied matrix A and B and then multiplied A and C and then added the products together. And for any real numbers K and M, if K is a scalar, we can add these two matrices A and B together and then multiply it by that scalar K, and it's going to be the same thing as this. We're going to just multiply and get a product here and multiply and get a product here, add them together. It's going to be the same thing as that. And we can add the K and M together and then multiply it by A, and it's going to equal the product of K and M and A added together. And we can do the scalar K times M and then multiply it to A, and it's going to equal M times A times K. See? Our next video is 13.5a, and we're going to talk about identity matrix and, whoops, I'm missing an N, aren't I? An inverse of a matrix, and we don't divide matrices. We change the division problem into a multiplication problem, and we multiply one matrix by the inverse of the other. It's going to be a link in the description to those 11 previous videos for Chapter 13. I'm going to add this to the Algebra II playlist, and we'll continue on and talk about inverses. All right? Have a great day. I'll see you next time. Bye.